Yesterday we talked about generating equivalent expressions. Remember, an equivalent expression is one or more problems represented differently but that equal the same value. Turn your page, please, and I want you to scratch out example E, F, and G if I did not get there with your classes yesterday. All right, that lets me know when I'm grading this that I don't want to count that against you. And we're going to pick up with example 1. We're going to pick up with example 1. So example 1 is talking about a property of operations that we've nicknamed any order, any grouping. And specifically, we're going to focus on this property when we're dealing with addition. That means when we're adding like terms. So prompt A asks us to rewrite the equation 5x plus 3x and 5x minus 3x by combining like terms. Write the original expressions and expand each term using addition. What are the new expressions equivalent to? I'm going to model rewriting 5x plus 3x and get to the final answer. Then I'm going to ask that you do 5x minus 3x independently and type your answer into the box. So when I am dealing with 5x's and I want to write 5x's in expanded form, that's going to look like x plus x plus x plus x plus x. And notice I used some parentheses to close it out. I'm going to zoom in, and I want to make sure that I have 1, 2, 3, 4, 5 copies of x. Because I'm repeatedly adding 5 copies of x, I could quickly rewrite that as 5 times x. All right, now I want to show that being added to 3x's. So in another set of parentheses, I'm going to have x plus x plus x. All right, so this is called expanded form. I have taken a short problem and I have expanded it out. Now I want to use expanded form to tell me how many total copies of x do I see. How many total copies of x do you see? Yeah, you should see 8 copies of x. So rewritten as 8x because 5x plus 3x does total 8x. Let's do the exact same thing. Let's do the exact same thing with 5x minus 3x. Again, remember we're wanting to use addition. So I'm going to give myself a little squiggly line down the paper so that I have room to do 5x minus 3x. Alright, so I'm going to start first by getting down my first term. Alright, so 5x's. 5x's looks like x plus x plus x plus x. So I have 5x's and I want to subtract 3 of those x's. Oh, sorry, that's just 4x's. Happy I checked that. 4 plus 5x. I have 5x's and I want to subtract 3 of those x's. If I am taking away these 3 x's, how many x's am I actually left with? I'm left with 2 x's because 5x, take away these 3 x's, leaves me with 2 x's. Any order in any grouping is a rule that means we can group or rearrange factors and summands, okay, that's terms of addition or multiplication in any order. Because both terms have the common factor of x, we can use a distributive property to create an equivalent expression. That means we're going to take the like term out of the expression. In each case, the like term is going to be x. So if I wanted to write an equivalent expression to 5x plus 3x, okay, an equivalent expression to 5x plus 3x, I'm going to take the like term out of each expression. So I'm going to take this x out. And now in my parenthesis, I am left with 5 plus 3. What would my equivalent expression for 5x minus 3x look like? Yeah, I'm going to do the same thing. I'm going to take the x out of the expression, and I'm going to have 5 minus 3. Try to find a value of x where 5x plus 3x is not equal to 8x, or where 5x minus 3x is not equal to 2x. Use a variety of positive and negative rational numbers. Were you able to find any values where you could substitute x and 5x not be equal, 5x plus 3x not be equal to 8x? What about 5x minus 3x? Yeah, it should have been pretty difficult for you to find any examples where you could substitute in different values and get a separate answer. Specifically in example 1, you can see that the commutative and the associative properties of addition are used in consecutive steps to reorder and regroup like terms so that they can easily be combined. Here, okay, I took the expression 5x plus 3x, I identified the common term, x, I took it out of the expression and I regrouped this so that I could easily add together those coefficients or the whole numbers 5 and 3. Once I've added them, once I've regrouped them in a sense to where it's easier to see, I can now say that I have 8x. Let's move on to example B. Find the sum of 2x plus 1 and 5x. First, let's write the expression. So I'm going to have 2x plus 1. I'm going to put that in parentheses. So that's my first term. It says and. Remember, and is a convention for addition. And 5x. Alright, so I've written the expression. My next step is going to be to use the associative property to regroup the terms. Remember, the associative property tells me that I can associate each of my terms with another term, but still have an equivalent expression. Let's say I want my 2x alone. Using the associative property, my new expression would look like 2x plus 1 plus 5x. I can now use the commutative property. I can use the commutative property to help me switch the order of terms inside my parentheses. What would that look like? Yeah, that would look like 2x plus 5x plus 1. Again, in each row, I've just generated an equivalent expression by applying a property of operations. On the second row, I applied the associative property. And on the third row, I've applied the commutative property. Let's use the associative property to rewrite this expression another way so that I'm grouping together like terms. Remember, the associative property allows me to change the order of all of my summons or the numbers that I'm adding. Yeah, using the associative property one more time, I can say that 2x plus 5x plus 1 is an equivalent expression to the 3 expressions above. Because of the associative property, I can apply the distributive property to combine some like terms. So, I'm going to remove the term that's the same in each number inside the parentheses. I notice that there's an x attached to each coefficient, 2 and 5. So I'm going to rewrite this to say 2 plus 5. I'm going to bring the x outside the parenthesis. And that's now going to be added to 1. It's now going to be added to 1. Now that we've applied the distributive property, let's simplify this expression. Okay, remember we want to use our order of operations. We want to go from left to right of the equation. So I have P, E, M, D, A, S. So our paper. I do see parentheses, so I want to handle the operation happening inside of my parentheses. On the left, I see 2 plus 5. That's going to give me 7. All right, so I'm going to scratch out my parentheses. That's the only parentheses I see. I don't see any exponents, so I'm going to scratch out exponents. Next, I want to handle multiplication or division, whichever comes first from left to right. I'm now seeing that I have this 7 I'm dropping down everything else I didn't touch. Zoom in so you can see that a little better. 7 times x plus 1. When I multiply 7 times x, what do I get? Yep, I'm going to get 7x and plus 1. Is my answer in simple terms? Why or why not? My answer is in simplest terms because 7x and 1 are not like terms. If there was an x with this 1, I could combine them to say 8x's. But because 7x is considered what we call an apple and 1 is considered what we call an orange, I cannot combine those like terms. I'm going to go ahead and circle that problem. Let's do some checks for understanding. Why do we use the associative and commutative properties of addition? Hopefully you said we reordered the terms in the expression to group together like terms so they could be combined more easily. And remember that's the goal of the associative property. The associative property tells me that I can reassociate terms inside and outside the parenthesis. And the commutative property tells me that I can reorder terms inside the parenthesis. When I moved this 1 from the parenthesis with the 2x into the parenthesis with the 1, and then I used the commutative property. It put the 2x and the 5x closer by each other. That allowed me to put them in their own set of parentheses and isolate that 1. Did the use of these properties change the value of the expression? How do you know if it did or didn't? And the properties did not change the value of the expression because each equivalent expression included the exact same terms as the original expression, just in a different order or in a different grouping. 2x plus 1 plus 5x is the exact same thing as 2x plus 1 plus 5x, which is the exact same thing as 2x plus 5x plus 1, which is the exact same thing as 2x plus 5x in parentheses plus 1, which is the exact same thing as 2 plus 5 times x plus 1. All of these expressions are equivalent to 7x plus 1, which was our final simplified expression. How can we confirm that the expressions 2x plus 1 plus 5x and the expression 7x plus 1 are equal? So how can I confirm that 2x plus 1 plus 5x is equal to 7x plus 1? What could I do? I could substitute the same number for x in each of the equations, and when I get a number on my left side and my right side, both values should be the same. Let's do that. Let's substitute the number 3 into both the left side and the right side. What is the value of both expressions when x equals 3? Okay, when I substitute 3 into the first expression on the left, I get 22 following the order of operations. And when I substitute 3 into the simplified expression, I get 22 following the order of operations. Because the expressions are equivalent, I could have picked a value other than 3. I could have picked a value of 7. And when we substitute 7 into both sides of the expression, I am going to generate the same value because I have the same terms on both sides. Let's go ahead and push to example C. Example C says, find the sum of negative 3a plus 2 and 5a minus 3. Yeah, we want to use the associative property, the commutative property, and the distributive property to help us rearrange the expression. First thing we want to do is write down the expression. I'm actually going to come over here because I have more room to start at the top of my paper. So I'm going to write down this expression. I'm going to say negative 3a plus 2, and remember, and is a convention for addition, plus 5a minus 3. I noticed that in my second expression, I am being asked to subtract 3. In the previous example, I was being asked to add my second expression. So because I'm being asked to subtract 3, I actually want to add the opposite. I'm going to use what's called the additive inverse. So rewritten, this problem would look like negative 3a plus 2 plus 5a plus negative 3. All right, I want you to notice the parenthesis inside of parentheses. If it helps you to use brackets, that works as well. Because I'm doing the exact same thing here, I'm just saying I'm adding a negative 3. That means I am subtracting 3 from this expression. When I rewrite an expression using the additive inverse, it makes the operations of any order and any grouping easier to apply. The associative property tells me that I can rewrite this because I see addition in between each term to say negative 3a plus 5a. I'm going to put that in its own parentheses. Plus 2 plus a negative 3. I'm going to use brackets for that expression because I'm using a parenthesis inside of it. It's going to be easier for me to combine like terms now because I put my coefficients with variables in one parenthesis and I put my whole numbers in another parenthesis. When I combine negative 3a and 5a, what is my final answer? Yeah, I'm going to get a positive 2a. My number is going to end up being positive because I'm starting at a negative 3 on a number line. And I want to move 1, 2, 3, 4, 5 places to the right. Okay, because adding 5 would move to the right. So this is negative 2, negative 1. I've crossed over 0 into my positives. Positive 1, positive 2. My answer is going to be 2a. That term is now being added to positive 2 minus 3. So I can start at positive 2 on my number line. If I am subtracting 3, what would my final integer be? 1, 2, 3. Remember when we're subtracting, we move to the left on the number line. To the left of 0 is negative 1. Let's say I want to get rid of add plus negative. How could I rewrite this expression to say the exact same thing but only show one operation? Yes, I would say this is 2a minus 1. What was the only difference between this problem and those involving all addition? Yep, first we had to rewrite the subtraction as addition. Then this problem was just like the other problems. Right, the associative and commutative properties can be used with another operation. That operation is multiplication. We want to use the any order, any grouping properties of operations to help us find the product of 2x and 3. All right, you should be able to rewrite this expression at least 2 different ways. Let's start by writing down the expression. So when I want to find the product, that means I am multiplying 2x by 3. I'm going to use the dot in between the terms to show multiplication of 3. 2x times 3. The associative property to regroup the terms. So this is now going to say 2 times x times 3. When I use the commutative property, remember the commutative property is used inside parentheses to reorder our terms. reorder the terms, what does our expression look like? Yeah, it's going to look like 2 times 3 times x. When we use the commutative property to reorder, that's going to allow our like terms to be closer to one another. All right, so I can easily see, using the order of operations from left to right, that I am going to handle the multiplication of those terms, those coefficients 2 and 3, and I'm going to get 6, and I'm left with the variable x. Therefore, the product of 2x and 3 is 6x. Let's do another check for understanding. All right, in example 3, you have a few examples you can do on your own. Please use any order in any grouping to rewrite the equivalent expressions for B, C, and D. Again, I'll be checking for these on your notes when you turn in this packet at the end of class. All right, let's look at it. Go ahead and scratch out E. Let's look at F. F says, Alexander says that 3x plus 4y is equivalent to 3 times 4 plus x plus y because of any order in any grouping. Is he correct? Why or why not?